Well, happy Sunday, everybody. Um, Happy Weird Sunday in Weird America.
Yeah, I just had a socially distanced brunch outside with like 10 people in masks, and then there's a curfew tonight, and protests tomorrow. It is weird, America.
Is is there a curfew? Is it in Oakland or is it all of the Bay Area or what's the deal with that?
I know that London Breed announced a curfew for San Francisco for 8 p.m. onwards.
Got it.
So I presume Oakland will also follow suit.
Yeah, yeah. Um, okay. Well, maybe we can get into that a little bit more if the mood strikes at the end of the stream. Uh, I definitely haven't been a super happy camper about the news lately.
Oh
Uh,
no.
yeah. Um, what games are you playing lately, Dom?
I just finished Final Fantasy VII,
The remake or
the
the
remake.
original? Okay.
The remake, very very fun, very strange.
Yeah.
I have a lot of thoughts on what they're trying to do to the story, and I think it's they're trying to save Aerith from dying in disc two.
Ah, okay.
Yeah, yeah. By making the entire first disc about fighting fate and defeating it, uh, they're ready to change fate for the next one. So
Got
honestly,
it.
a bit of a cop out.
Yeah, I feel like Eris or Aerith dying in Final Fantasy VII, even though I'm not nostalgic for that game whatsoever, was like the key moment in all of Final Fantasy, right?
Yeah, yeah, and it was I don't know. It really fucked with people, and it's interesting. It's hard to make the same story now when everyone knows that's coming. So I mean, I assume that's why they want to do something different. Uh,
Yeah.
but yeah, it's a little weird. I have
So
lots of
is
thoughts.
it?
We should do a Final Fantasy spoiler stream.
Yeah, yeah. Is it? So you're saying it's fun. Uh,
I thought it was a very fun game to play. Yeah,
okay. So like combat wise,
the combat was delightful, and it has a hard mode that's like really skill based. Yeah,
nice. Do you play games on hard? Are you a hard mode person?
I like doing hard. You have to beat the game once to get to hard mode, and then it unlocks some other challenges. Uh,
Wow.
but when
Okay.
given the option, I usually start on hard and see if I can muster it, and then go down to normal if I can't.
See, I'm the exact opposite. I start on like the lowest difficulty setting, and I generally just coast. And I feel like that speaks to some deeper character flaw. That's sort of maybe a microcosm of what has been constraining and limiting to my life.
There you
you know.
go.
Um, so I have been playing. Speaking of that, I've been
Yeah.
playing the Yakuza series. Do you know those games?
I saw you online playing Yakuza Zero the other night. And I almost started it right then.
So I actually played Judgment a
Hmm.
while ago, and Judgment actually is the most recent game in that series. And it's not about it has like a different main character, um, and but like the same setting basically. One of the brilliant things about that series is they're able to like essentially just reuse the same environment, like the same
Yep.
4 or 5 city blocks, and then churn like 8 games worth of content out of it.
Hmm.
Uh, but they do a really good job with like the kind of modern noir storyline. It's about kind of organized crime and hard-boiled yakuza dudes or PIs or whatever. And there's always some like sinister government slash corporate slash higher up in the yakuza kind of like conspiracy that you have to sort of unravel over the course of a game. Anyways, I've been playing that game on easy mode, and it's been great.
Yeah, I've only played Yakuza like one, the remake.
Yeah, Yakuza Kiwami.
Kiwami, yeah.
Yeah.
Extreme, apparently is what that means.
Oh, yes, nice.
Um, but I loved it, and it definitely felt sort of like a PS2 game, but the story was so good that it really like carried me through and I like cared the whole time. So
Nice.
I'm excited to experience like a more modern one in that series. And it sounds like Zero and Judgment are both right in there.
Yeah. Zero feels a little bit more PS2-ish. That's the one I'm playing right now. I
Hmm.
basically got the the Origins bundle for PS4. It comes
Ah,
with Zero, Kiwami, and Kiwami 2.
cool.
So I just have like the next month and a half of or 2 months of video games kind of lined up
And
for
then
me.
you can get 3, 4, 5 to just keep going.
Right. And but if you play Judgment, Judgment definitely feels like a PS4 game, and it feels
Nice.
really, really
Okay.
modern. Um,
Heck
but
yeah.
I like Yakuza. What I'm enjoying about it right now, relative to Judgment, is the arcadiness of it. Like you hit guys, and money comes out of them, and then you can take that money and then spend it on your ability to hit guys more effectively and more
Yep.
efficiently.
Aren't
Yeah,
aren't you also, isn't that the one where there's a mini game where you're running like a host club or a hostess club and
yeah.
it's like a
There
whole
are two
property management
exactly. Yeah,
subgenre?
there's two main characters, and uh, like the main character of the series is Kiryu, right?
Hmm.
And he gets to run a real estate business in
That's so
Kamurocho. It's
fun.
amazing. It's a great kind of like capitalism slash protection racket simulator.
Hmm.
And then I haven't gotten to the Hostess Club running one, but
Okay.
Majima, who's the other guy,
I love him so much.
he's awesome. He's like apparently like this incredible like fixer at a Hostess Club. That's like a 1930s jazz big band jazz club. Uh,
This is great.
yeah, yeah. That game comes close to the line so many times. Like at least you're not a pimp, you know.
Hmm.
Like at
Hmm.
least there's a lot of things like I'm willing to simulate. Right, playing Division 2, I'm basically simulating being like a Tom Clancy right wing like
Yep.
vigilante kind of
Hmm.
person.
Hmm.
I don't know how I would go. Like if there was like a pimp simulator, I don't think I'd be able to do it. Right, I think there's like a certain line I couldn't cross.
That seems good though.
Yeah,
I wouldn't want you to have to cross that line. I feel like especially there's this like subgenre of organized crime video games, and it's like Grand Theft Auto, the
yeah,
Mafia series, and Yakuza. And I think the Yakuza one handles it with the most like humor and self-awareness of like
yeah.
how bad the thing the characters are nominally doing is.
Right.
And like the protagonist is like a good person who's like, well, I need to eat, and also like no one's gonna abuse the women of Kamurocho on my watch. I'm just like, okay, great. Like you kind of understand, you know, the humanity of what you're doing versus like Grand Theft Auto, where it's just like you probably are a pimp in that game somewhere. It'd be like the
Yeah.
least surprising thing to happen.
Yeah, totally. I think the Yakuza should probably be called, like spiritually speaking, the name of it should be like not all Yakuza, right? That's basically that's kind of the spiritual through line is that like, the
Hmm.
main character is this like fundamentally good dude with like a very, very strong sense of integrity and like a code of honor, but he's also schlepping it for a
Yeah,
parasitic organization, you know.
but I feel like I can only imagine that most games end up with him fighting his boss, which sounds great. So
They do, yeah. You beat the shit out of a lot of Yakuza like
yeah,
overlords
it's
in the
great.
name of protecting the Yakuza, right? Like it's incredible. Um,
You're gonna enjoy one when you get to it. The whole thing is so enjoyable.
yeah. Oh boy, I'm suddenly reminded. I actually studied history in
Mm,
college, and the guy that I probably learned the most from was this crusty Japanese history professor named Irv Shiner, and his big thing was peasant protests
ooh,
in like the Tokugawa period. And his big thesis statement is that there was like a lot of like protest and unrest. So this is topical. This is
there
top.
you go.
We're sort of refracting modern America through feudal Japan, basically. And his sort of thesis statement was that like a lot of the peasant protest that went on during that era was about getting authority figures to play the role that they claim that they should be playing. So like,
Hmm.
every sort of power structure has this like legitimizing mythology, right? Divine right of kings and all that stuff. And I
Right.
guess the protests in that age, which were apparently quite violent and pretty nasty, were ultimately about like, no, it wasn't about like I'm a peasant and I want to be king now. It was more about like we should get the kings to like behave like kings, kind of thing. And so that's the Yakuza video game basically. It's like the Yakuza need to act like Yakuza. There are some bad
Hmm.
apples, and Kiryu is gonna go in and like shape him up with his fists.
Oh, I like
Yeah,
that.
yeah.
Yeah,
So let's talk about tanks. Let's talk
do
about
it.
video games. So today, I think our goal might be. I love how you can drive the tank around, uh, even though I'm the one sharing screen. It's fantastic.
This program is wonderful.
Yeah,
I've been doing interviews recently, and some of them are just like, "Yeah, Zoom is bad. We use Tuple for sharing." And I'm like, "Yes, I know what that is.
yeah,
I'm already
yeah.
set up with a
Tuple's
good
great.
account."
Tuple's great. Um, so right now, Dom is shooting the yellow triangle, which is a turret. We don't have cool graphics yet, but we want that to be kind of like our first enemy entity. Um, and what we'd like to have happen is maybe that turret to actually sort of turn and face the player, and maybe even shoot at the player. Uh, we want to add what is, I think colloquially known as adding some AI or some AI behaviors. We're not talking about sort of fancy neural network Elon Musk AI. No simulation narrative AI. This is just like getting the turret to kind of behave in a somewhat programmatic fashion, which maybe is what we can try to shoot for today. But before we dive too deeply into that, I want to talk like another hour about peasant protests. No, I do want to talk about a couple of developments that have been going on off stream about like what we've been
Mhm.
going on, been doing so far. So if I can take over the mouse again, first of all, just as a recap, we actually have tools for
Mhm.
for building the game now. Um, and as we're probably going to learn over the course of this stream, maybe in a month or two, like when we talk about game development, what we're really talking about is like game tool development. Over time, what becomes most important is not the code that you write, but about like how can you convert creative ideas and get them into the game as quickly and efficiently as possible, and
Mm.
that's about kind of like tools. So the first tool that we made was this cool particle builder where we
Mhm.
can kind of tweak and modify a bunch of different parameters of a particle emitter and then copy and paste them in. And we can use this sort of design explosions and that sort of thing, right? So following that, the second tool that we've started to work on is a map editor. Right now we have like this sort of like really sort of janky map editing system, which is basically in source code directly, where we use ASCII characters to represent different tiles and also ASCII characters to represent different entities. We have a turret, which is represented by the letter T, and then W means wall, and P means the player, very literal. And that's sort of what's being translated into the playfield right now. But eventually, we'd like to be able to kind of like design these using an interactive and graphical tool that allows us to maybe overlay the entities on top of the the terrain tiles and that sort of thing. And that's what this tool is eventually going to become. Right now, all it is this ability to kind of like paint grass, and you can paint mountains, and you can also paint water. And another cool thing about this is you can zoom in and zoom out, right? And you can kind of move around the map. And eventually, we're going to be able to export this and then load it into the game. And there's also going to be the ability to paint not just terrain tiles, but also entities and things. So we can place
Mhm.
walls, we can place trees, we can place turrets on that.
Oh, that's
And
cool.
then, yeah, yeah. And then eventually tag the map and entities and things with all different kinds of metadata, right? So it might be interesting to sort of tag waypoints or to tag
Mhm.
rectangles on the map that mean different things in the game.
I've seen that a lot in stuff I've been reading, but I feel like a lot of game development is putting invisible cubes or boxes into the game that are
Yeah.
triggers, but like it's basically an entity with a script attached, right? Like when you collide with it, something happens.
Yeah. And using the entity as that vehicle is basically like, do I have something that roughly behaves like an entity but just doesn't have a visual
Yep.
component to it? But there are other things that you can do. You can create geometry. You can create giant rectangles. You can do all sorts of other things. And since we're building the engine and we're building the whole game, I think we have a lot of freedom on exactly what kind of constructs we want to put into the map. Um, okay, so that's the kind of like main development that's been going on off stream. But this particular tool has, or this set of tools, plural, has kind of motivated a thought that maybe we have needed to sort of refactor some of the things that we've built in the game so that it's
Hmm.
easier to replicate patterns across really what's now 3 different programs, right? We have one program, which is the game itself. But we have 2 different tools now that like are separate programs, but they're going to sort of utilize similar patterns as each other. And um, we want to be able to kind of like make sure that we're not repeating the same code over and over again. So I thought maybe I could talk a little bit about like some of the stuff that I was doing with the renderer code over the last couple of days.
Yeah, please, because I haven't
Maybe
even
spend like
fully digested that.
10 or 20 minutes on this, and just so we can kind of understand what's going on.
Mm-hmm.
So at a very high level, what I've done is I've changed the render so that we used to be passing in both a render context and a camera into the render function. And the pattern would be that essentially every object would consume both of those objects, the render context and the camera, and then draw itself into the render context, right? And the render context specifically is the browser, the official sort of W3C browser API for drawing 2D constructs, right? Drawing rectangles, drawing lines, and that sort of thing. And that's what you get when you call this function here. And what I've done is I've kind of tried to abstract the browser away a little bit, and also abstract the camera away a little bit, so that when objects sort of draw themselves, they actually don't even draw themselves. They basically just describe what their geometry is, or they describe how to draw themselves to some other object which knows how to like apply that to whatever render target there is. And our render target right now is just the canvas render 2D render context, but it could be OpenGL or it could be something else.
Ah, that's sick.
Yeah. I think abstracting away the rendering backend wasn't my first goal. For me, it was really just kind of reducing code, if possible. So if we actually go into the game render, you'll notice that the game now has a renderer object on it. And the renderer is just an interface. I'll just show you what it looks like. The render interface is super simple. Basically, it says I can either clear the whole screen or the whole view. I can set a transform, which I'll talk about what that actually means in a second. Or I can render a particular renderable. And what is a renderable? Well, it's up here, right? A renderable, I'm using this wonderful kind of like union type syntax from TypeScript. So glad we're using TypeScript.
Yeah.
Best decision ever. And a renderable is like one of 4 different types of objects. It's a path, and a path is sort of the 2D equivalent of a 3D mesh, right? A 3D mesh is like a bunch of triangles, and a path is actually just a bunch of points on a 2D plane that you connect with a line. And that's what we're using to draw, for example, our tanks and our turrets, right? They're just paths. They're paths of 3 points. A rect is a rectangle that is described as basically the position of its northwest corner and then a height and width. There are circles, which is actually we can actually just take a look at some of these objects here. A circle is basically just a position and a radius. And then there's lines, which is basically like a starting point, a finishing point. I use the words from and to for that, and also how thick you want the line, which is described by this width. And then all of these also have some sort of styling parameter here, which basically tells the browser like what color to draw or something like that. Now, one of the funny things about this is that it still doesn't abstract the browser away completely because we're using browser-based color systems here, like a fill style. Right. Actually, for rectangles, we also have... What's that?
You have a hex color in there, essentially.
We have hex colors, or we can use color names. We can also use RGB function call, like CSS style RGBA function calls. We also have a struct. Yeah, it is really nice. And so again, I don't think my goal was entirely to just like abstract away the render context. I just didn't want to pass the render context into other objects. Like, why make the render context a dependency of an entity, for example? When really what you need is you just need an entity to say, okay, I have a particular path. I'm just going to tell you what that path looks like, and I'm going to let something else worry about how to draw it, right? So if you look at how the game is constructed, that's actually kind of like what we're looking at here interface-wise, is that we're basically saying, okay, the play field, which is our background here with all of these like terrain tiles, is gonna just have this set of renderables. They happen to be a bunch of rectangles, and the renderables again are just any of these things. And
Mm.
I just want the playfield to return whatever the renderables are, and then for each one of those things, I'm going to tell the renderer to render it, right? And we just repeat that pattern for entities, and we repeat that pattern for particle emitters. For particle emitters, it's actually each emitter has a set of renderables in and of itself, right? And that's just like one renderable per particle, right? And all the particles right now are circles, basically.
Yep.
Yeah.
Now, it looks like, are we off? Do we have a half pixel thing happening in the game again?
Yeah, we do because the walls are not they're not flooring their positions. And so
Okay.
I can talk a little bit about how the positions are getting set, and we can decide if we want to fix the bug now. We can actually that's actually not a bad way of exercising our understanding of what's going on here.
Yeah, exactly.
Yeah. Okay. So this is actually, I think what Dom is pointing out here is basically a camera problem, right? When we if I reload the screen, we don't see that
Hmm.
off by 1 pixel. But if we move around a bit, right, we start to see it a little bit, and it's because we're
Oh yeah, and there were some
basically
lines
no,
between the rectangles too. Yeah.
yeah. This is the case when we draw rectangles or we draw paths that are flush against each other, but are basically being represented using floating point numbers, which don't align to a pixel grid 100%. And the renderer, the browser renderer rather, is trying to like very faithfully render the floating point numbers to the best of its ability, and there's going to be a little bit of gappiness and error as a result of that. Now we solved that last time by basically trying to snap every view position basically to the nearest pixel, or not even the nearest pixel. I think we were rounding down in all cases, right? That was sort of like what we were doing. Um, so let's talk a little bit about how we are basically changing positions in the world or in the game space to positions inside what we can see right now, right? Um, because right now the tank is basically, relatively speaking, always in the same spot in the view, right? On the screen, it's always
Hmm.
like halfway down and halfway across, except when we get close to the ends where we allow the camera to kind of stop scrolling. But when we're sort of in the middle here, the player is always going to be in the very, very middle of the screen. But
Hmm.
relative to the world, it's actually moving around a lot, right? We're actually moving around in the world quite a bit. So we have to do a lot of translation between spaces, right? I don't want to get too heavy into the linear algebra, but the idea here is that we're actually dealing with a couple different ideas of space. We have the space that the game is simulating, which we'll always call world space. And then we have the space that is being rendered, which we call view space or a screen space. Um, and then there's also a space that uh, the paths are being represented in, which is model space. And I'll get into that a little bit. But the way that we sort of translate between these two is through transformations. And that's what this line here is basically taking care of. What we're telling the renderer here is that the camera basically is what's following the player. And what we're telling the renderer here is like, I'm going to send you a bunch of renderables whose coordinates and measurements are in terms of world space,
Hmm.
but I want you to compensate for that because the camera has actually moved somewhere, right?
That's cool.
Yeah. So this paradigm we actually take completely for granted in 3D games. That's the only way you can do it in 3D games. Is you have this idea of transforms, but
Hmm.
for 2D games, it wasn't super obvious that we needed to do that. I happened to move to this model because we actually accidentally made our game 3D, or we made this engine 3D because um, we built this map editor tool, and I made it 3D by adding zoom. So I needed a way of dealing with 3D
Oh,
transformation as a result.
I see how we got here. Okay,
Yeah,
cool.
yeah. Okay, so um, quick exploration of spaces, right?
Hmm.
Um, so we start with model space. and I'm borrowing some of this terminology from 3D games, but I think the analogy is actually, it's not even an analogy. It's like, I think these are totally appropriate terms for 2D as well. We go from model space to world space.
Hmm.
And this is when we want to draw something. Model space to world space to view space. So what is model space? Well, let's say we want to draw our tank. What exactly is the tank actually? In terms visually speaking, it's a triangle,
Right.
right?
Right. It's the big triangle.
Yeah.
Little triangle.
And the triangle, where did we actually put the player? Is it under player?
It should be the player's path renderable. Yeah.
Yeah, player here.
Hmm.
This is the path that we were talking about, right?
Hmm.
And what that actually is it's actually a set of coordinates that looks a little bit like this. I don't know if this is exactly correct,
Hmm.
um, but the origin is here relative to these points that we defined, right? We have 0, negative tile size minus 0.5, so that's upwards on the y-axis, and then we have a couple of points here and here, right? And these are all relative to some imaginary origin, right? So we have 3 points here.
Hmm.
Now, what we actually want to do is, first of all, we want to apply whatever transformations to the model that will basically allow it to render in the world. And the first thing that we do is we want to rotate it, right? Because the tank can spin around, right? So the first thing we do is we apply some rotation to these points, right? That's the initial thing.
Hmm.
Now, the rotation is still going to be a set of points around an origin, right? So we're going to go from this to maybe this, right? We've rotated.
Yep.
But we actually want to know, like, where is this in the whole game simulation, right? Which is where we go from model space into world space, right? So the way that we do that is that the entity has some notion of a position, which comes from our transform component, right?
Notably, that's also where rotation's coming from, right?
Yes.
Do you consider rotation a transform into world space as well?
Um,
And you applied it in
yes.
an order,
Yes,
but
I
it
do.
is
We
part of like
applied
the
it in
world
order.
space.
Yeah,
Yeah.
you're right. Right. So actually, the rotation is already a move into world space because
Yeah.
basically, model space is like our human notion of left and right. Like it doesn't matter where you are in the physical world. Left and right is always like totally constant relative to your position, right? And
Exactly.
your head is always above your feet, right?
Hmm.
Uh, but in the world, left and right really aren't concepts anymore, right? That's actually like, well, we're actually north of something or south of something, right? Um, and so I think rotation is technically a part of the world space transformation,
Hmm.
right? So we'll rotate and then we'll translate. And translate just means like, let's actually move this from being sort of tied to the origin of whatever space we're in to actually some place in the actual physical world. So the world, maybe the entity's control point is now actually here and it's rotated.
Hmm.
So now the 3 points of the path are very, very different to where they were originally up here, right? Over here, they were sort of relative to the origin and very, very simple. But once we get to this into world space, it's actually the points are actually now quite different, right? Now, the final transformation that we have is going from world space to view space. And this is where the camera comes into play, right?
Hmm.
Wait, let me back up a second. So the way that we actually do the transformation from model space to world space is that, again, we have this transform component, right? And this has, as Dom clarified, both the orientation and the position. Right. We used to have a function in this path 2 called apply translation or something like that, or apply transformation. I just got rid of it, and because the renderer takes care of that now. If we go to the 2D canvas renderer, and we go to the path primitive, we just do that here. And what we're doing is we're taking the transform, again, we're taking it off of let's see, render interfaces. What is a path described as? A path, well, it has a model to world transform. So like the letters here actually already describe what we're going for here. Model to world, right? And we just basically apply that transform to every point on the path. That's what's going on in the renderer itself. It's saying, okay, I'm going to go ahead and apply this transform. It's actually doing transform composition here, which is like a slightly more advanced concept. But the idea here is that we're basically doing this. We're doing this transformation, bringing the model, which was originally looking like something like this, into something that looks like this, right? Okay, so the second thing we have to account for is, this was the first thing we did, this is the second thing we did, is the world to view space translation. And that's where the camera comes into play, right? So the camera actually has a world space position, which I refactored to mean its center point. But that means that there's like kind of this invisible box around the camera in world space that is actually visible, right? This is sort of like the visible box around the camera. And view space is interesting because the origin of view space is actually this upper left corner, the northwest corner, right? And so what we want is we don't want this vector from, we don't want the vector from the origin of world space. What we actually want is we want the vector from the origin of view space, right?
Right.
So we need to apply a transformation that accounts for the position of the camera and also the dimensions of the camera. And I also added the concept of zoom as well, right? Because what zoom does is it says, well, actually, the view space representation, the representation of the view in world space actually is smaller because we're zoomed in a little bit. We're actually zoomed in.
That's cool.
Or it's bigger because we're zoomed out, right? Yeah. So zoom and the position of the camera are both properties of the camera. So we get this second transform from world to view space. We get that just from the camera. And that's why we're just pulling out the camera here. We're just saying, hey, give me the world to view transform. And the way that we get that is we basically say, there's a series of kind of like mathematical things that I won't get into here. We can talk about it later if you'd like to. But basically, this composes both the zoom and the position of the camera and the dimensions of the viewport, and gets us to a matrix. So it turns out that we can actually combine transformations before we apply them to individual points. So this is nice because it's actually a little bit faster. Like if this path was like 1,000 points, we might not want to like apply the model world transform and then the world to view transform to every single point in sequence. What we want to do is combine the model to world and world to view transform into one transform, which is like the model all the way to the view, which is what this is here. And then we apply that to every single point. Yeah.
And wait, that's handling orientation as well.
It is handling orientation, yeah, because the model world transform, yeah. Let's actually take a quick look at how that's working. Path renderable. Actually, it's the transform component, and this is actually where GLmatrix is nice. GLmatrix gives us stuff, right? So basically, we have this mat2D, which is a 2D transform matrix, which importantly is not a 2D matrix. Really quick. A 2D matrix looks like this.
Correct.
A 2D transform matrix, which is a matrix that transforms a 2D vector,
Hmm.
actually looks like this.
What?
It's a 3 by 3. Yeah.
Huh.
Uh, and it's a little bit confusing, but basically what this actually ends up boiling down to when we're talking about scaling, rotating, and translating is that scale and rotation is this piece right here.
Hmm.
And then translation is this piece.
What? Okay. And wait, what is the 0, 0, 1? Is that simply flattening this on the z-axis so it's a 3D transform that's actually a 2D transform?
Yeah, this is us cheating basically.
Great.
This is basically how we cheat to use matrices to basically do this kind of thing, because essentially we have this notion of ordering operations. We rotate before we translate, right? Which is different than translating and then rotating, right? If we translated and then rotated for this model up here, we
Hmm.
translated first, what would actually happen is we would translate the model to here,
Hmm.
and then we rotate it around the origin, right? Which is
Right.
not what we want, right? So the way that you actually bake in ordering is that you actually jump up a dimension so that you can kind of strictly order things. So let me actually just show you really quickly what that's like. So a scale, like if I just did the identity in this upper left corner, if I just did the identity, but then I wanted to like move it on the x-axis by 2 pixels and on the y-axis by 3 pixels.
Hmm.
And let's say our original position was 1, 1. And then we just fill in 1 here. This thing here is like a dummy.
Oh, interesting.
It's just a placeholder. And if we do that matrix multiplication, we get 1 times 1 plus 0 times 1, which is 0,
1.
plus
Yeah.
2 times 1, which is 3. Then we get 0 times 1, which is 0, plus 1 times 1, which is 1, plus 3 times 1, which is 3. So we get 4 here. And then we get 1 here. So you notice that like putting the translation here just means it gets added on at the very end. The
That's
upper left corner,
that's
sorry,
weird. I
upper right
love it.
corner for the upper right corner for the x-axis and then the row down for the y-axis.
Hmm.
That's basically so. Uh, if we were actually to change this to 2 and 2, what we'd be doing is scaling the x and y axis by 2. We'd be multiplying those numbers by 2 first, and
Ah.
then adding the translation, right?
Huh.
So
Okay.
that's essentially like if we get to 3D, the transform matrix will be actually 4 by 4. It'll be a 4-dimensional matrix to do three-dimensional transforms in this
Interesting.
style. Yeah, and it's basically a mechanical convention. Every time I look at matrices, I'm like, oh god, I get scared. You know, like I feel all this like linear algebra imposter syndrome.
Oh yeah.
Um, but the thing to I think remember with matrices is that all they really are is a shorthand for basic arithmetic operations. It's just someone figured out how to like combine all of those a sequence of steps into a very compact format. A matrix is actually a little computer program. It's literally just like a computer program that somebody learned how to like compress down and essentially compile down, right?
Right.
Um,
It's so neat. And I love that GeoMatrix is just doing this for us. Like the tools look great. It's nice not to have to write this all by hand.
right, right. Yeah. So the model to world is basically saying I have this 2D vector transformation matrix, which again is actually a 3 by 3. And what we do is we do one for translation, one from rotation, and then we multiply them together to create one that does both of them at the same time. And the ordering is actually right to left. So when you do this multiply, I actually had to just like trial and error this. I didn't know like what order was correct, so I just like
Hmm.
I put R before T first, and then I did T after R because it looked weird. But basically, what this is saying is I want to have one matrix that applies this orientation first and then adds on this position as a translation. And that's what this is.
Cool.
Yeah.
Man, that's really slick. Okay, so now we have a lot more tools in our tool belts to work with here.
Yeah, exactly. And then that'll again with the camera, I did something very, very similar. Only I added zoom as well, and it also does shaking as well. So the shaking is like another dimension on top of this, which is just like,
That's
but you can
great.
compress all these things together, right?
Hmm.
And what it is for the path when you render a path is you can actually take the model world transform, and this dot transform again is actually the thing that we set in the renderer, so it's actually variable. You can actually change what this is
Hmm.
globally, basically. And in the game, what we set that to was the camera's worldview transform. And the reason why I
Cool.
made it this global thing is that it's going to be the same thing for everything down here, right? It's going to be basically I want to what I'm saying when I say this set transform worldview is that all of the renderables I'm getting from everything after this point are going to be world space renderables. They're all expressed in this space right here, this world space, and I'm going to be transforming them into uh, the view space here, right? Yeah,
Man, this is great. Okay.
yeah, and I'd be
Wow.
happy to go deeper into the math like off stream or whatever,
Yeah.
because it's like kind of good to get this stuff at least conceptually in your head of like what's going on, because like I think if we get to there might be a way that we can do sprites like this as well, but I'm not 100% sure. But um, right now, the
Why?
fact that we're doing primitives is nice. Yeah.
Oh, you. What would stop us though? Because I think Canvas just has a render image for pixels, like at a point. So it feels like it's probably very.
I don't know how to do trans. I don't know how to do like zoom in and zoom
Oops.
out. I don't know how to do zoom in and zoom out for
Gotcha.
images. I'm pretty sure you can. I'm pretty sure you can say I've got this like 30 by 30 ping, but I
Hmm.
want to render it in a 15 by 15 area in the canvas itself. I'm pretty sure you can
Yeah,
do something like that.
I think it just works.
Yeah.
We should. I'm excited to get the sprites because it'll, I think, really make this.
Yeah.
It'll make some of this pop, and I don't want to draw all the pixels with path renderables.
Yeah. So, anyways, one thing I want to show you is that in the
Yeah.
Canvas 2D renderer, this is getting to the bug that you pointed out, right? Let's go
Right.
back and see if we can't dig it out.
I can. Yeah, there it
There we go.
is.
We can kind of see it, right? Look, if I zoom in, it'll become much more obvious, right?
Yeah, I can. Oh gosh. Whoa.
Is it more visible? You
A
see,
little
it's a little
bit.
gappy there.
Yeah. Yeah, I can see the gap in there for sure. Oh yeah. Oh, there
Yeah,
was
we
some good
see
ones in
we've
there.
eliminated the gap completely now, right?
Hmm.
But let me see if I can't get it back. Yeah, there we
Ooh,
go.
that's
Right.
big. Yeah, and it's nice
Yeah.
you can see that the yellow is actually over the blue. Like things are happening where they shouldn't.
Yeah. So the reason why that's happening is that basically after we do this transformation for our paths or for our rects for that matter, um, we're getting fractional values. Like
Hmm.
this path, which is an array of vectors, is coming up with stuff that supposed to be in screen space. It's supposed to be in views, and the view space ultimately is composed of I don't know how big is our thing now, 400 by 400, or it's actually some number of tiles, right? Like it's
Right.
I forget how big this actually is, but like basically, um, uh, we are getting fractional values, but they should actually be pixel coordinates,
Hmm.
right? And actually, with rectangles, I actually accounted for this because you notice we're not seeing that drift. We're not seeing those gaps between the terrain tiles because those are being drawn using rectangle primitives.
Oh, that's interesting. So the walls are actually a path renderable of a rectangle.
Yes. So we could actually
Great.
solve this one of two ways. One is we could go to wall, and what is the renderable here?
Well, but the turret had the same problem. The
You're saying
turret
the
actually
turret was kind of moving up and down.
it overlaps with the water at certain positions. Yeah,
Let me see if I can.
I saw it happen. You really didn't have to. Let's
I
see.
don't have to zoom in. Is what you're saying?
Yeah, you don't have to zoom in. You just need to drive down the screen. There you go, right there.
There you go. Yeah. So maybe what we should be doing is actually, I made this on rectangles. We solved that problem by basically rounding down for all of our positions.
Hmm.
Um, but maybe I think what we're saying is we should just do this all the time.
I think everything should be rounded down for this. Yeah,
Okay.
we want to be
All
on
right. So
pixels, guaranteed. Yeah,
let's do that then.
cool.
So really, I think all we just do is like we take this transform matrix and we round it down, right? And let's see if that solved it. I think it solved it, right? Let me.
I think so. It's hard to tell till the camera moves. It's much better though. Yeah, yep, yep,
Yeah.
yep. Well, that's nice.
Yep. Very cool. So I think we might be able to do that to everything. And I actually made this. It's funny. I made this an optional thing on rectangles, but I think what I'm hearing is that we should probably do it for everything, right?
I think so. Yeah.
Okay. Cool. Well, we'll go ahead and fix that for rectangles, also circles and lines. I'm actually
Mhm.
we do it for lines anyways. See, we're doing it.
There you
We're
go.
doing it in
Yeah.
lines just automatically. And the reason why I did it for lines is that we have these lines here. We have these grid lines
I
in
was
the
wondering what
editor.
the line primitive even was used for. That makes
Yeah.
sense.
And the line primitive, the lines are actually world space constructs, right? Because
Huh.
they actually represent positions in world space. So they're actually being rendered in world space. Um, which is why you don't see them moving left and right, or it's why they actually seem to move when the camera moves. Because
Right.
if they were,
Right.
if the lines were in view space and they were just like every tile in view space, they would appear to just be like overlays, or like they'd appear to be like a heads-up display or something like that.
Hmm.
Yeah,
Man, this is a cool little thing. I'm
yeah,
so stoked.
yeah. And I think when it'll be really cool is like when we start completely taking it for granted. Like when we start to hate the tools, when we know that it was useful. Yeah, because we actually have to do real work in it. Yeah. Okay,
Sweet.
so that was the long side about the renderer, and that's essentially the big architectural change. There's really two of them. One that we're no longer passing the render context or the camera down into individual render functions,
Hmm.
and the second thing is that uh, we've changed a lot of our like transformation stuff from like a bunch of ad hoc functions that were in the path renderable class and inside the camera. Remember the camera? We had this like two render position function. It was essentially
Yeah.
exactly the same thing as the world to view transform.
Hmm.
We just didn't represent it as a matrix. And representing it as a matrix makes it a little bit harder to understand, but it also allows us to compose transformations such as uh, the one that we did with the path up here, right? We actually composed this one, which is the world to view matrix by the time that we get to here, and the model to world. So if you go model to world and then world to view, it's really this ultimate one is model to view, right?
That's
Yeah.
so cool.
And one last thing that's really cool about having that world to view matrix is
Mhm.
if you go to the camera class, the thing about matrices is they're invertible. Okay, so you can actually go the opposite direction. You can take a world to view transform and turn
Mhm.
that into a view to world transform. So it says basically, if I'm hovering over something in the view, and you do this because the cursor is in the view space, right? Your cursor is floating over somewhere in view space, and I want to know
Oh,
where in the world, like which tile I'm actually adding when I click there.
that's how
You
that
need to actually
works.
get the world. You need to actually get the world position based on that view position, right? Um,
That's so cool. Holy
so
cow.
you basically just take the matrix, this worldview matrix, and you call invert on it. And I actually have a function in here that I
Hmm.
use to draw these grid lines. I wanted to know, like, I don't want to draw like every single grid line in the entire world because the entire world doesn't fit into the view. I only want to draw the ones that are in the view.
Yep.
So what I said is like basically this function here gives me the visible minimum and maximum points in world space coordinates of what the camera can currently see. And so what I do is I just say, here's the world view transform. I invert the matrix, and then I use that inverted transform to transform these view coordinates, which is the origin of the view, which is basically the northwest corner, and then the dimensions represents the southeast corner. I just transform them using that inverted transform. That gives me the world space coordinates as a result. And I can use that to basically know which grid lines to draw, right?
Oh man, this is
Yeah,
sick. Yeah, that makes a lot of sense.
cool.
Very cool.
Yeah. So the matrices are a little bit harder to grok, and they are intentionally an obfuscation. It's a difference from going from source code to compiled code. It's the same thing from going from like individual arithmetic operations that are easy to understand, like translations and rotations, into a matrix is basically a
Mhm.
compilation of those things, right?
But there's a lot of there's like hardware acceleration of matrix multiplication, right? Like these are operations that are actually like, they're in the GPU pipeline or something for
Yes,
like
or at
I think there's
least,
like there's some hardware unit that can do these faster.
yeah. And if it's not full matrix math, it's like dot products, right? So like even like modern
Mm,
CPUs, like all of the kind of like vector registers, like the 128-bit registers that you have, or there's probably registers now that contain 4 or 8 64-bit floating point numbers, right? And then you can like probably dot products. And a
mhm.
dot product is basically it's basically what you do when you multiply one matrix row by one matrix column. Like it's like one of those operations on a matrix is basically the dot product operation.
Gotcha.
Um,
Yeah.
yeah. So at the very least, CPUs have that capability, and you just do those like n number of times in a row, and you have a matrix multiply, right? Um,
No, it's great. It feels like pre-baking it for performance in an interesting way.
yeah. And basically, what a GPU is like a piece of hardware that can do those things massively in parallel,
Hmm.
and then also like rasterized triangles, massively in parallel as well. Yeah.
Yeah, I was looking at like whatever the new consoles are, and they were just like, oh yeah, we have 54 GPU units running in power. I was just like, oh okay, this is actually like that is quite a few more pipelines than I expect like a computer to have for just like running running JavaScript through the CPU. So it's
Yeah.
really neat.
And the GPUs have gotten a lot more generic over time. It
Hmm.
used to be that they were very, very highly specialized, and you couldn't do things like branches very efficiently. So, like if you
Mm.
had like an if statement in your shader, it actually made the shader a lot slower to have to do an if because like it's essentially you're
Hmm.
essentially like waiting. It's a very, very inefficient operation that blocks the entire pipeline from doing anything. It's actually true on CPUs too. That's why we do branch prediction, right? Like it's like CPUs are now simulating versions of the future. Like if you get to like a jump that's based on some kind of like branch not equal or branch if equal kind of thing, it's actually just evaluating both sides and then just like picking the future because it's able
Uh,
to calculate both sides simultaneously, right?
it's so mind-blowing, and I love that we have CPU level bugs that are like branch prediction let
Yeah.
someone get into protected memory before they had access because the branch predicted. I'm just like,
Yeah, I mean the problem with the problem with the sort of simulation of the branch not taken is that it has side effects, right?
yep.
It populates cache and that kind of thing, and that's the whole Spectre and meltdown thing, right? Like that's like the crazy world we live in is now that we have basically have very little like either intra process or inter process security anymore
Hmm.
because of the fact that like CPUs are so predictive. But I don't know
So
if
weird.
GPUs operate the same way. I'm not sure if they have the same. I'm not sure if GPUs are considered to be super scalar, at least for like a single line of
Hmm.
code. But they basically have a GPU is essentially like a ton, like 64 individual CPUs that are all running code, right? Uh, yeah. Anyways, uh, so that was a long digression into matrices, rendering, that kind of thing. We'll get back to the level editor, I think, off stream. We actually want this thing to
Hmm.
be able to render entities. The whole point of me refactoring the rendering stuff is so I could render entities without having an entity construct in the map editor tool itself.
Well, and that's great
Um,
because I had to put like a tiny little camera into this thing to get it to work at all. So
yeah.
I assume you refactor that away, or it's like just the default now, but it's great.
Yeah, it's funny. The particle editor still has a camera, but it doesn't need one, right? Like we could
Cool.
actually take it out right now just to give you the
Do it.
um, yeah, so particles
Yep.
index.tsx, I believe is what it is. So I
Hmm.
think we create a camera, and it's funny, we set its position to like
The
the
center.
middle of screen space or in the middle of the world, which is there. And
Mhm.
then I think we set the transform. Yeah, we set the transform here on the renderer. But what
But
all
you could
this
just
really
set that
needs to
transform.
be is basically all we need to do is we just do render dot set transform of mat2d from translation.
Hmm.
And are we subtracting or adding 200?
We are
I think we're
adding.
subtracting, right?
Mm, that's a good question. It's not adding?
We are, well, let's see. A particle is here, which means that it's, let's say it's like half a screen up or a quarter of a screen up from the origin of the camera. But what we
Hmm.
really want is the vector from the upper left corner, right?
Oh, right. Oh, that's hard.
Um, right. So I think that let me try subtracting first, and then
Yeah.
we'll go from there. So we set the transform here, and it never changes, right?
Hmm.
In the game, we're actually constantly updating the transform because the camera's moving around and it's being up.
Hmm.
It's like following the player, and also in the map editor, it's also moving around because we can control it. But that doesn't need to be there. Now that the camera's gone, we just get rid of this thing,
Hmm.
and we can even get rid of the camera import here.
Sick.
Okay, so this was wrong. Kind of moved the wrong way.
uh, Here's a question. Is it actually 0, 0? We don't, there is no camera to world space translation for this thing. Like, the entire point is that the camera is actually 400 by 400.
Oh
Yeah.
yeah, you're right. You're right.
Yeah, I was doing a lot of work to get everything to render in world space coordinates on this screen. Even better.
Yeah, and the particle emitter. Oh, that's interesting because the particle emitter is translated.
Because it's
That's
rendering
why.
in the center of world space. Yeah.
Yeah, so probably if
Oh,
we just set this
yeah.
to 0, 0, maybe this makes a little bit more sense.
I think so.
And
And that
so this is
positive,
probably
yeah.
positive 2. So Dom
Cool.
wins. It is adding. Yeah, this
Well,
makes a little bit more sense.
yeah, I like that 0 was the right answer too. And then yeah, so this is what we're actually doing is we're rendering the particle emitter
At the
at
origin.
yeah, world 0,
World
0,
origin.
and we're
Yep.
taking the camera and knocking it up 200 pixels. Okay, cool.
Yep.
Yeah.
Yeah.
Well, this is neat.
This is accounting
That's
for the
rad.
fact that the view's origin is the upper left corner,
Hmm.
whereas the world's origin is like the center. Yeah.
Yeah,
Cool.
looks good.
Um, yeah, and if we wanted the camera back, the reason why we do it is because maybe we wanted that. Well, we wanted to do zoom here. Maybe we wanted to move around or do zoom here, but
Zoom
like
would actually be
something
very
we can
interesting
add.
if you made an emitter that was bigger than the current space, for instance.
Yeah, yeah.
But I keep this in here because this is definitely what it was doing.
Okay, fantastic. Okay, so let's change gears completely now, and let's talk about getting that turret to do something interesting, right?
Make it spin.
Okay, so should we move the turret? Should we move it to some place that's maybe a little bit easier to reach,
Yeah,
or
absolutely. Can you just put some more dots
what?
on one line and will it render? Yeah,
Yeah, the dots
does
don't
that
matter.
work?
They're just placeholders.
But I
At
think
least
you
I think
might
they're
need
just
to. I think you might need to at least have that many dots at
on the
on the
first
first
line.
row. Yeah, we probably do row dot 0.
Yeah,
Well,
that's
that's
too many,
freaking
anyways.
cool. I love
Yeah,
it.
I'm gonna get rid of some of these walls as well.
Yep, yep.
Um, actually, I'm
Cool.
gonna get rid of all these walls.
Hmm.
Okay, so maybe the first thing we want is for the turret to always be pointing at the player.
Yeah, and I was thinking that the rotation, like it has to have like an acceleration, right? Like it's not just gonna like snap to player. So it should be chasing the player, like rotating towards a point at a certain speed.
Yep. So let's build up to it. Let's do this.
Yep.
Let's do the. Oftentimes, the dumbest thing is the thing that is actually the most terrifying, right?
Huh.
The dumbest thing would be to allow the tank to basically snap to the player, like basically to always like be pointing at the player directly, and that would
Yeah.
actually make it for a really difficult
It'd be a
gameplay.
very hard turret. Yeah.
Yeah. Okay. So, oops. How do we even update the turret?
Hmm.
Right. If we look at an
Great
entity,
question.
entity is these things.
Hmm.
Maybe it's the mover.
I think it's the mover. Yeah.
Okay. So let's go to the turret class. We don't even. Oh, we do have a
It's
turret
turret index. Yeah.
index. Yeah, we have a turret folder. And what we want to do is we want to add a mover to that. Mover
Hmm.
comes before wall, right? Um,
Hmm.
should we just do new mover here?
Yeah, and just make the class in. So we don't want the player mover. So let's maybe just create our own. Yeah.
Yeah, I'm gonna just do that class here, and then we
Yeah.
can move it to a different
Absolutely.
file. Is an I mover or is it I generic component? I don't remember.
I think it's a generic.
Yeah. Okay.
Hmm.
And then that that interface is this update function here.
Hmm.
And we need to get the game.
Hmm.
I'm going to use your thing that I learned last time. Oh,
Yeah.
that's so good.
Isn't it? It puts it the. It's a funny place to do the import though.
You mean at the bottom here?
No. Does it need to be a slash? Tilde slash is what it actually wants, right?
I think tilde without the slash works.
Okay. As
Um,
long as it's chill.
and I think I prefer the tilde slash, but I'm almost tempted to not add the slash in there because this automatic thing just doesn't add it in there. If we could train VS Code to add this, then I just want one way of doing things. It doesn't really
Same.
matter
Agreed.
which it
Okay.
is. Okay. So we need to know where the player is.
Hmm.
And so there's a couple different ways that we could look for the player. One is we could pull it off the game,
Hmm.
or the other is we could pull off the entity manager or something like that. Or we could tag the player with some kind of like a player component that doesn't really do anything.
Mm.
Last time we ever had to do like where's the player is when we wanted the camera to lock on the player, right?
Yeah.
And the way that we dealt with that was through this hack down here. This is us setting up the map. This is an initialization function. I think this is just the constructor of the game.
Okay.
And we take the map, which again came from this,
Hmm.
and we basically said wherever we find this, we're going to instantiate that entity. Oh, I did a whole refactor of creating entities here, but don't worry about that. It's not that interesting.
Okay.
Um, and we said if the entity type is the player, then literally store a pointer to the player on the game itself.
Okay. So game has the player. I like that. I think let's if we can just grab it off the game object, let's make that public.
Okay.
Because surely this won't be the only thing that needs to know what's happening to the player. And
Yeah. So just so you know, one other way that we could do this is we could iterate over the entities, and basically we could have entity have like a player component
hmm.
the same way that we did with walls,
Yep.
right? Or we could have like a tags component that stores a series of tags, right?
I really actually like tags because ultimately the turret, well, A, there could be multiple players. So the turret could maybe want to find the player that is closest to track. If players
Yes.
are, if there's a multiplayer system or something. Um, and perhaps, we have a friendly turret that fires at enemy entities. So what you want to tag is an enemy tank that tracks the closest. Like, so I see why grabbing the list of entities by tag makes a ton of sense.
Right. Right.
And lets the behavior of an object be extremely configurable. Yeah.
So for the time being, that's where the
That's
puck
where
is
we're
going.
going.
Yeah, that's
Yeah,
where we're going. But for the time being, maybe what we can do is just say that the game has a player on it.
I think it's reasonable because like we'll know what to do. We know what to do when we want to modify, like, or we want to have more complex behavior. And I think since we have such a clear path for it, that feels great.
Right. I need an entity.
Really.
Oh, that's not going to get it. I need. Wait, I can have it do
Yeah,
it for me.
do it. Do it.
Nice. Um, okay, so now that we've got that, the turret can find the player very, very easily, right?
Hmm.
So now we want to know. We want basically a. We want to determine the turret's rotation, right?
Hmm.
And how do we determine rotation?
We want the arc. We want the arc between straight up and the player's position relative to the turret. Yeah. So do we have to
And
draw some? Do we have to draw some triangles here?
these are our relative positions. This is the P is player dot transform dot position. T
Hmm.
is turret dot transform dot position.
Hmm.
Um, we could very easily get this vector,
Yep.
right? And then we consider the orientation to be this theta angle. Right? It's
Hmm.
the clockwise rotation off of the vertical axis.
Yep.
Um, so one way we could do that is let's call this angle like phi.
Hmm.
And what this vector actually represents is this distance and this distance,
Hmm.
right? This is delta x and this is delta y
Hmm.
in the negative axis. Um, so is that basically arc sine?
Oh lordy. That's been a hot minute.
It's SOHCAHTOA. I always have to remember that. Opposite of it's actually arctan. That's right. That's why all games. That's what games actually do tangent all the time, right? Arctan. If the tangent equals opposite over adjacent, the opposite here is delta y
Hmm.
over delta x. But we're also taking. We're not actually looking for phi. We're looking for theta. So is that pi halves minus that, something like that? Well,
Does that
it's
cover the full rotation?
it's for the rotation.
Does it cover a full circle of rotation though? Uh,
Yeah, I guess we. Yeah, that's a great question, right? Because like, what happens if the angle's oblique, or if it's
yeah.
reflex, right? Yeah. So why don't we just start with the arctangent, see what the turret does, and
Is
then kind of mess with it.
there is a vec2 dot angle between two vectors function.
Oh
Would that
yes,
help us? That would help
that
us.
would definitely help us.
Yeah,
Back to
because just dot angle and then vector A and vector B.
and let's actually take a look at the source to see what it's
Mhm.
doing. Oh God, what's my browser doing? I think this is GitHub, right? Um,
Possibly. You could make it wider. Your whole screen's on the stream, so if you want to stretch it, stretch it. Math dot.
it's doing the arc cosine of. They're doing some kind of galaxy brain math there to figure
Yep,
it out.
yep.
Arc
That's cool
tangent is
though.
generally, I think, what people will do in these
Hmm.
cases. Um, but yeah, anyways.
Yeah, but so what we want to take we would like to take the angle from this, like this vector, and like anything we get from there, right? And that'll do it.
Yes, it's from pointing north to whatever the
Mm-hmm.
player's position minus the turret's position is, right?
Mm-hmm.
Okay, wonderful. So to player equals g dot player
Mm-hmm.
2 dot subtract back 2 dot create. It's actually player dot transform dot position. This dot it's actually entity, which is the turret. Transform dot position, and then
Oh, sorry.
no problem. What we want is this dot transform dot orientation, actually e dot transform dot orientation, to equal the angle between
Mm-hmm.
pointing north, right, and
Mm-hmm.
to player. Um, and that should be it, right?
Yeah. Yeah. Okay.
Okay, so that looks like
Wow.
that's almost right, except
It's only getting half of it though. This half of the circle is great.
yeah.
Once we're on this side, it's actually backwards.
Once we're
And why is that? Because so like the positive, well, 1 pi is good. X positive from the turret is looking correct.
yeah, so basically, what how do we number quadrants again?
I think is it
It's,
1, 2, 3,
I
4?
think you're right. One, two, three.
Oh, that's probably it. Yeah.
This is fine. This is fine. This is
Yep.
no good. It's no good.
No good. And like I I feel good that it's the reverse at least.
Yeah.
Um,
Um. So
is it possibly the subtraction you're doing?
so the subtraction I'm doing is
Because
p minus t,
mhm,
which will give us the vector from the turret to the player.
right. Yeah.
So I don't know. What I actually suspect here is there's actually not a single tidy. There's
You just
not
need
like
to do
a
it
single
twice. Yeah.
tidy thing that we can do here. I think we actually need to know, like, is the vector pointing to quadrant 1 and 2, and if so, then what we have implemented is fine.
Mhm.
However, if the vector is in quadrants 3 or 4, then we need to negate the angle, or we need to do pi minus the angle, something like that.
Right. Right.
So let's try that. And I'm not saying that I fully grok the math, but we can give this a shot, right?
Hmm.
So if so, what does quadrants 1 and 2 actually mean? It just means that the x value is positive, right?
Yes.
If to player 0, and I'm not actually sure what happens if the x value is 0. Like if you're exactly on the same vertical line as the player, who the hell knows what's going to happen here? We'll have to play with it.
Hmm.
Else e dot transform dot orientation equals. There's a lot of different ways we could do this, but let me try this,
Cool.
and we'll see what happens.
Hmm. Okay. Oh,
Okay,
so
that's
I think it's pi plus that though, because
like
it immediately snapped to the top, but we need to get like the second half of the circle. I think your 0 to 1 was also correct. So it's like getting the next, yeah.
Okay.
Hmm. Sick.
Awesome.
Hmm. Does it start off when you do a fresh refresh? Does it not? Oh, it is oriented at the player immediately. Okay, great. Before it wasn't because it couldn't point at this side.
Oh, the prettier doesn't like my. I really like doing this style of comment to kind of like label the
Me too.
branches.
Yeah. Not into it.
Yeah.
Sorry.
Actually, I think this isn't the worst thing in the world.
Nah.
Okay. Is there a way I can make this a little more consistent? I wonder if that'll do it. No. All right. I'm not going to claim I fully understand the math here, but
Well, yeah. You could do. I guess you could multiply that by a negative vector if you wanted to keep it the same thing both
yeah, I could
times.
I could invert this, right?
Yeah. Yeah, I think so. So
Let's
if you wanted to calculate that first and then invert it and add it to pi for this branch. I was
negate.
thinking, oh, let's see what this does.
All right. Now we're just throwing shit at the wall and seeing what
Yeah,
sticks.
I'm curious. So that's correct, and now you add pi to it.
Oh, I mean this. I think it's relatively clear what we did here. It should be like getting the angle between either because we just like which do you negate? Do you negate this or do you negate this?
Yep,
Right.
it's weird. I don't understand.
Yeah. Angles are funny, right?
Apparently.
Angles and
Yeah,
quadrants are.
I was looking at the Wikipedia definition, and it's for two vectors. It's arccosine of the dot product of north vector to player vector over the what is that absolute value but for a vector? It's not a dot product.
Absolute
Hmm.
value of the vector is the length of the vector. It's the
Okay.
mag. Yeah.
Magnitude. Yeah. So it's dot product of the two vectors over the magnitude of the two vectors multiplied. Interesting. Arccos of that.
Yeah. Because I think that's maybe what the angle is doing because like the dot product is the like a dot b is equal to a1 b1 plus
Hmm.
a2 b2, which is also equal to the magnitude of a times the magnitude of b times the cosine of the angle between them, right?
Interesting. Yeah.
Yeah. Which I think essentially I think that's kind of like what we're doing here, right? We're getting anytime you see a square root, that means we're doing Pythagorean theorem, which is we're getting the
Hmm.
magnitude of the first thing, and this is the magnitude of the
Yep.
second thing. So yeah,
Yep.
this is doing exactly what you're talking about. Cool.
Cool. And then wait, go back to that. Sorry. Where
Yeah.
was the
Where's the
what's
arccosine?
oh interesting.
The arccosine here. Oh, and then I think maybe
This is
clamps.
actually it's interesting because this is doing a different this is doing like a slightly different algorithm. So I wonder why.
They're trying to make sure that the value of
I think they're doing a thing that will force us to only get values between 0 and pi. Is that correct? That at least explains the
yeah,
output.
I think what is the output of arccosine? What does arccosine even look like graph wise?
Right.
Arccosine is one of those. Arccosine is one of these.
Huh.
I believe arccosine of it's like one of these things, right?
Yeah, I think
Or if that's arccosine
think
or
it's
oh, and then
uh
obviously like it actually probably does a zero crossing at the
yeah, weird.
one of those. Yeah.
Okay, I have questions, but also this looks great. So
Yeah, I think the output of arc cosine is not. It's from 0 to pi. I don't think it goes
Yep.
higher than that. And that's the problem that we're wrestling with here.
Yeah. Yeah. That's okay. Uh, our solution is good.
Yeah, and anytime you have a function that like is disjoint, that's why like the disjointness is expressed in the code, right? Like we have like two different branches here. Yeah.
Yep.
Okay, fantastic. All right, so you were saying
Hmm.
let's actually give it some lag, right? So
I
let's
think so.
so basically there's basically it's going to be a difference between what the orientation of the turret is and where it should be pointing.
Hmm.
So what we're really saying is that like const target orientation.
Is this output?
Yeah, we can just yeah is this and then this is the
Prob
target.
Yeah, probably doing a let for that, and then we'll be good.
Yeah.
Yeah. Right. And then the anti-orientation is actually like current orientation, and then plus or minus. Like we didn't figure out what's the shortest distance. Like it can't always rotate counterclockwise or clockwise.
We're gonna have to do some more quadrant reasoning, I think, right?
Well, is it that, or is it just like we need to figure out if our current orientation to pi is positive, or like do we? Yeah, there's a branch for sure to figure out like to is it a smaller delta positive or negative? Yeah,
Okay, let's.
interesting.
So this math.pi means that if we're in quadrants 3 or 4, if the target is in quadrants 3 or 4, then the angle is going to be greater than pi,
Hmm.
right?
Yeah.
Um,
Oh,
so this is
interesting.
theta. That's our orientation.
Hmm.
It's north. It's also negative y. Um, and sorry, we realized I was talking without even writing this. Let me actually just narrate that one more time, just so
Okay.
you can follow what I'm saying. So we have our axis here. This is north.
Hmm.
Theta represents how far we are around this rotation, right?
Yeah, and it's interesting. We're not. It's like no longer an angle. I guess that's why the function is only giving us half because angles can't be greater than 180. Then they're just like your angle is smaller on the other side.
It's either greater than
It's like
180 or it's negative, right?
right, right, exactly. So it's we're working in radians and not quite an angle, which is I guess why we have to
Yeah, I
think
also
think about
kind of
this as a
wonder
split.
if we did this.
Mm-hmm.
Why is it having a problem with that?
Oh, line 30.
And then let's just do this or e dot transform dot orientation equals
Uh-huh.
target
Target.
orientation for
Yep.
now.
Oh,
And let's not negate this.
not gonna do that.
What did I just
Uh,
do? Declare.
two main parens. Yeah.
Okay, I like this better. I think this is a little bit more. This is a little bit easier to reason about.
Yes.
Yeah.
Oh, very much. And also, yeah, I would consider even unbranching a little bit and setting it to the default and only negating it for one branch. But actually, this is nice because at least you see both quadrants. Nah, don't listen to me.
I know exactly what you're getting at. I could go either way.
Yeah.
All right. So back to this picture.
Hmm.
This is actually no longer what we're talking about, right? We just changed it to a different picture, which is if we're in quadrants 1 or 2, theta is this. But if we're in quadrants 3 or 4,
Hmm.
theta is this. But it's like negative, right?
Right. Right.
Yeah.
And this is actually probably is this the first time we've had a negative radian in here? Maybe not actually, because if you rotate the player counterclockwise, I assume we're subtracting some value from the orientation and just making a bigger and bigger negative number.
Yeah. So
Okay.
we need to. I think we need to make sure that our orientations are normalized
Yeah.
one way or the other, which means that like when we What is normalizing? Is it keeping it above 0, or is it keeping it within the range negative pi pi?
Hmm. Hmm.
Now, in order to simplify this math, we've kind of elected to normalize it by keeping it within the range negative pi and pi.
Yep.
But I imagine when we do orientation, well, as long as we represent the entity's orientation in the same space, either
We're
between
fine. Yeah.
we're fine. Yeah.
And the player orientation doesn't matter at all. So it's
Yeah.
okay. Okay. So I guess given our orientate, so we need to know what our current orientation is and figure out which way we should turn, essentially.
Correct.
And okay.
So there's a lot of different possibilities here.
Yeah.
So there's actually 16 different possibilities.
Oh no.
Well, it's not 16, actually. I'm sorry. It's 4 different possibilities.
Mhm.
The target and the current, positive and positive, positive and negative,
Mhm.
and positive, negative and negative. Right. Those are the 4 different possibilities. And in each case, we need to know what the behavior should be.
Mhm.
Right. So
Yeah.
let's play it out. Right. Like, let's say the target is positive, and it's
Mhm.
tricky too, right? Because it's not just these different possibilities. Because I can imagine even within these possibilities, you want different behavior, right? Because like your target could be here, and then the current could be here, and what you want is to move this way, right?
Mhm.
Or the target could be here, and the current could be here, and what you want to do is move this way.
Mhm.
And in both cases, it's this positive and negative
Right.
situation, right?
Right. Exactly. Oh man. Mm.
So what if we took the difference between the two and then
Okay.
normalized that, right?
That seems like a good place to start. Yeah. I,
So,
is this,
yeah,
yeah. No. No. It's okay. Our coordinates are normalized into pi to negative pi, so we can add and subtract these just fine. Yep. Great.
yeah. Let's make it like a
Let's
normalized angle.
yeah, and maybe let's do the dumb thing,
Yeah.
which was your suggestion in the game, but let's actually just like set it. Let's do our acceleration and have it rotate towards the player, and then we can figure out how to change direction maybe.
Oh, got it. So it might turn the wrong way, is what you're saying.
Yeah, yeah, it'll be exploitable, but at least we'll get some of it in there.
Okay. Let me at least get this normalization
Yeah.
in there. It's like if theta greater than math.pi,
Hmm.
uh, return if it's greater than pi, then what you want is the negative of that minus pi. Is that like
Yeah. And should this be, well, should this be recursive? Should you do return normalized angle theta minus math dot pi and make sure that it's not like a couple pi's above it?
I
Like,
see what you're saying.
hey man, I only
Uh,
get to write recursive functions once every 3 years, so
if we are, oh, I see what you're saying.
yeah, just normalize that value and make sure we're still in a safe space.
Yeah.
It probably won't go too far, but at least we can count on it like always being correct if it is somehow way out of left field.
If it's recursive, I think what you want is if it's greater than if the absolute value is greater than 2 pi,
Mhm.
you basically want to do it. You wanted to get that value like modular. You wanted to do like the division by 2 pi, basically, or you want to do it you want to do like the modulus of 2 pi.
Can you do a floating point modulus?
There's f mod, yes.
What? That's cool.
I'm gonna say that with this function, we're
We're probably
normalizing at
fine.
every step. Let's say we're normalizing at every step so we don't get in that situation. Is that
Okay,
okay?
great. Yeah, I accept that. right, I just got an alert about a citywide curfew. The only people who are allowed outside are first responders, essential employees, and people experiencing homelessness.
Ugh.
The fuck?
So
Great.
we can't even like go out and grab food. Is
Not
that what?
after 8 p.m. you can't. But I guess essential employees are people delivering food.
The fuck is wrong with this world? This is insane.
Isn't it great that we finally had to like categorize people into like social strata
Yeah,
to
and
survive a
who are they trying
pandemic?
to protect here again?
I don't
Target?
know. Target, yeah. Wells Fargo. Those beautiful, beautiful windows that just can't be shattered.
Yeah.
This is an anarchist programming stream now. It's
If
okay.
you're a bureaucrat, are you thinking to yourself like, I've got the Chamber of Commerce barking up my ass, or the local regional manager of Target barking up my ass, or is it more like, this is the tacit way that I can suppress protest?
Does it
What's going
does
on here?
anyone think I want to suppress someone else, or are they just like, gosh, like I don't want this much chaos in my life? Like
Yeah, that's probably what it is.
I feel like no one's like oppression, but they're just like, man, smashing windows scares me. Like, what if it's my window? What if it's like my bakery's window?
You're right. It's
And
more fight or flight than there's not necessarily.
yeah,
It's. I actually imagine Mitch McConnell probably has some realpolitik going on in his head, but the local the
right,
local magistrate, is more like, these people aren't doing what I'm telling them to do, and so therefore we need to make sure.
right. The woke mayor of Berkeley just doesn't want there to be conflict. Not that like he thinks people are sheep that should be oppressed or that the police are virtuous, but
Yeah,
like please just don't start a fire in my backyard. And like I understand it, but also it sucks.
yeah. The point of protest is that there are times where there should be a little bit of a fire, right?
Yeah, like the fire is in your backyard. Someone already said it, probably the
Yeah,
cops, and you should maybe go put that out.
yeah. Oh, the cops.
Yep.
I was talking with Bunny last night, where it's easy to assume that this is the worst the world has ever been. But I was remembering, this is another hit. Well, I'm not talking about peasant protests in feudal Japan, but I am talking about in the 1960s, that Kent State University protest, where like
Mm-hmm.
the National Guard just went in and like shot
Shot
students,
people.
shot
Yeah,
white people. They shot white people. Yeah, like so it was pretty intense in the 60s, right? It was pretty intense.
yeah. I feel like we're actually hitting a very similar moment, uh, but we've got better cameras, and I really hope that because Kent State is looked upon just with such disdain, and they're just like, wow, we can't believe it got this bad.
Yeah,
I sure hope that like by the third time around, this time we take it seriously.
yeah.
I don't know. On the flip side, I have a family member who is in Chicago PD riot gear today. So
Ah,
yeah,
like a close family member, like someone you're on speaking terms with.
I'm on speaking terms with them for complicated reasons, but also like, you know, cutting them out of my life would be worse than not, probably. Uh, but all cops are also still bastards. There's no way around that.
Yeah, yeah.
It's complicated. Everything is really complicated.
Yeah, I mean, you can be a bastard and also be your cousin that you care about, right? Like that's yeah,
Yeah, yeah, and I think part of it is like conversations that were already hard is we're trying to dig into those a little more now to make sure that like we talk to the person we can affect.
yeah,
Yeah, it's fucked up. Everything. Ugh.
yeah.
We're only 2 months into quarantine, man.
Okay, let's solve trigonometry problems. It's a little bit
Great,
easier.
great.
Okay, so if theta is greater than is less than negative pi,
Hmm.
and I'm pretty sure we have some edge issues here. Like, what if you're exact at pi? But I'm not going to worry about those for now.
I think it's
That means
okay.
that you've crossed over to here. So what we should do is
Oh, right.
should we should we negate
Oh,
it
yeah.
at pi?
Wait a minute. looking back
Yeah.
at this code, oh, I have the wrong control. I need the mouse. Uh, if theta is greater than math.pi, don't we want to, instead of, so that's like, oh God, I'm gonna lose this before I even finish it. Yeah, okay. Um,
Yeah. Let's draw both scenarios, right?
yeah.
That's
So
this.
if it's over here, we don't want math.pi minus theta. Don't we want this minus 2 pi to bring it back to the negative version of this? We want to clamp it to the, yeah, we
Minus
want to
two
subtract.
pi will right. It'll be the negative version of the
It'll
same angle.
it'll it'll take it all around the same circle but back into our space. So I think the first one is minus 2 pi and the second one is plus 2 pi to keep it in our
Well,
space.
I don't know if it'll bring it back into the same space, right? Like if we subtract pi, it'll be here. Oh yeah,
Uh-huh.
and we subtract pi again, it'll be there. Okay.
Exactly. Yeah. We want to take it to the opposite circle. Yeah. And that's just the opposite. Yeah. Hmm. Cool. That feels right. Hmm.
Okay.
So did we want to normalize target orientation? Is that how where we started?
We could do that. Let's try it.
Okay.
So is that this basically what you're saying is like what we want is this equals normalize.
Wait, I think this actually has to go online, like on line 40 once we've already. Or what are we trying to? Maybe we're trying to normalize.
I think it's actually normalized when it comes out of the
Yeah, those two functions are good.
angle. Like that range is between 0 and pi, right? Or something like that.
Right. Maybe then what needs to be normalized is, so as we move from our transform to our target, we will maybe cross a boundary as we move in a direction. Like we'll probably go from, like, if we get to negative pi, we might start going to negative pi plus some delta. And that's where we need to normalize to be in the right space.
So what if we did this?
Uh-huh. Yeah.
And then what we would do is if this is where we need to do like kind of like floating point math, where it's like if we're roughly equal to a number, right?
Hmm.
Um, uh, we'll figure out exactly what this is, but like a, b, epsilon number, which I think people usually use like this number.
Whoa.
Um, if a minus b
Hmm.
greater than less than equal to epsilon, I just list that.
I see. True. Just return that, right? Yeah.
Yeah. If then we're if we're not equal to that, then we want to move towards that, right?
Hmm. Hmm.
So let's say that E dot orientation equals the normalized angle of E dot transform dot orientation plus
Hey, we just need to figure out if we're going right or left, right? This could be.
Well, the diff tells us that, right? I think the diff should tell us that.
The diff should tell us that. Oh, yeah.
I'm trying to figure out also how we avoid overshoot, but maybe that's not a big deal for now.
Yeah, I'm
What is
okay
our
with that.
rotation speed? What is our rotational speed?
Let's see. Are we in per second?
Yes.
Pi. Let's start there.
So it's basically half a circle per second. It's really
Yeah.
slow. That's fine. Okay. So
Is it really slow? Because I feel like the arc the player's taking around the turret is also pretty slow.
that is true,
Yeah.
especially if you're far away, right?
Right. Yeah. It's only if you get close up, it'll have trouble tracking you, which I think is like maybe an okay.
The sine of diff times dt times math.pi.
Cool. Oh, snap.
Let's slow it down a lot, right?
Yep.
Divided by 4.
That's cool. Jeff, that looks great. I'm into it.
Okay, cool. Let's
Yep. Yep.
this is a little slow, right? Let's do math. Let's do
Yep.
pi over 2, maybe.
Mm-hmm.
And so what we cared. Yeah, okay.
And I actually epsilon maybe could be a little bigger because I noticed when it's jittering still. It's doing some work. That would be nice if it didn't. Are you seeing that, or is that just an artifact?
Like, is it? Are you saying is it going back and forth?
I feel like yeah, I feel like at some of these angles, it looks like the turret is sort of vibrating, trying to catch the player.
Oh, I see it. Yeah, you can barely see it there.
Yeah.
So that's the overshoot I was talking about.
Is it just the epsilon needs to be bigger?
We could solve it that way. The other way we could solve it is to make sure that we cap this.
Ah, right. And that needs to
And
be
in
the
fact, I think we
max
should
of that. Say again, sorry.
yeah, no. I think we should actually do that. So basically, this is like um, this is the delta.
Hmm.
Uh, like this is the displacement,
Yep.
and then we could say if the displacement is less than or equal to math dot absolute value of the difference, then E dot transform dot orientation just equals the target orientation.
Yeah. 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 Yeah.
Otherwise, and we don't even need to do this equality stuff anymore,
That's
right?
great. Yep.
This is just displacement.
Hmm.
Does that make sense?
Yeah, that makes a lot of sense.
Okay, so hopefully that should get rid of our vibration.
Did it reload? I didn't even see it.
Yeah, let me unzoom real quick. It's too bad this scrolls when I use the arrow keys. If there's a way I could turn that off, that'd be great.
Yeah. Cool. That it stopped overshooting for me. Yeah.
It's
Did it
really
reload?
fast right now. I think we need to turn down its speed a little bit.
Hmm. Over 3? Yeah. Oh, sorry. Wait. I think it's actually on target orientation because when you give a fresh reload, it no longer turns towards the player.
Oh, I see what you're saying.
Yeah.
Oh, this is always going to be the case. If
That's
displacement is
always
greater,
greater than. Yeah.
all right. So that's way too slow, right?
I like two. Two is good. Yeah. And so yeah, it definitely like locks. That's great. Cool.
So when should it shoot?
Uh, that's I was thinking that it should shoot when it's like a certain distance from target orientation. So can the mover store the target orientation so we can get that in the shooter?
Yeah, we can or we can write a utility function that will just like we can call it any given moment and just pay the
Oh, that's
cost
cool.
twice, which is not, I think, that big a deal, right?
Yeah, let's do that because then yeah, the shooter if the transform orientation and the target orientation are like less than a zero point zero 0.01 radian, take a shot.
Yep. Where do we do the shooter? This is
I don't think we have one because the player shooter is a totally different thing as well. That
it is a shooter. It's a generic component. We don't
oh, I
have
just
something
mean
that abstracts away the ability to create bullets, but that's
is there?
okay.
Yeah,
Okay.
we should maybe next week or next stream we should do some tagging because your own bullets can hit you, and it'd be really nice if your bullets hit enemies instead of you know
We could
self-friendly fire.
turn off friendly fire. Yeah. And e dot shooter equals new shooter, right? Oops.
Mhm.
And so what were we saying? If your displacement,
Yeah,
what is it?
if
We have like get angular distance
mhm. Yeah,
from,
between yeah.
and it's a transform, really, right? Uh,
Yeah, to transform. Yep, exactly.
and that's all this shit, right?
Uh-huh. Yeah. Can we
Target
is
orientation is a little bit. This is what we want to rotate to it.
yeah,
I think it's this, right?
I think so, yeah, because diff we don't necessarily need all the time.
Um,
Oh, but we need the target orientation. So we can return the tuple of that.
Hang on 1 second.
Okay. Yeah.
This is 2.
Oh, I think you just made the same two different things, right? The
This one should be from.
that was from, yeah.
And then it's
What's up,
still
Prettier?
having complaints. Uh, whoa, how did that compile?
I don't know. I have questions.
That's really funny.
I mean,
And so
TypeScript error, maybe not JavaScript error.
we still need target orientation here, right?
That's what I was saying.
Um,
Yeah, you could return the tuple or just diff could be something that you got to figure out for yourself.
that's what
Huh?
that is, right?
Yep. Okay. That's true. Hmm.
Okay. So now
Nice.
our shooter is going to say that if we are within how much?
I mean, like, I was 0.01 radians, 0.05 radians. Yeah. I'm not sure how much that is actually. Oh, yeah. 0.01 radians is like, oh, that's 0.5 degrees. That's probably a little small. Point zero 0.05 is 3 degrees. So I think if you're looking at 3 degrees closest to the
Zero
player, that's
0.5
fine.
radians?
0.05. Yeah. Mm-hmm.
Um, we're going to, oh, fuck. We got to copy all this stuff.
I
For
just
now,
copy it
let's
all.
make a bullet, huh?
Just copy it all, yeah.
Okay.
Including the TTL, yeah.
How much do I need to copy? Not the keys, right?
Yeah, it's like
Not the
everything but the key.
keys.
You basically just like that if is the new key function. So you could take line, yeah.
I can take all this jazz.
Yep. Yeah, and just paste in 68.
And then maybe I'll reverse this. So if diff is less than this, or this is less than diff, we'll just return.
Okay. Yeah, unnested code.
Yeah, this one makes me slightly uncomfortable, but I think it's okay.
Just the copy pasting, you mean?
No, I almost always like doing the early outs and
Yeah.
then have like, but in this case, like it means that like you have to know at this point in code that the rest of this stuff is about shooting, and if you add anything else that's not related to shooting, then all the shooting stuff should have been indented in the first place.
Right. Here, wait. Let me command Z some real quick. Okay.
Okay. Oh, and then yeah, let's get all this stuff in there.
Mm-hmm.
Make bullet. Did we?
It probably comes from it's the bullet constructor, right? It's yeah.
Yeah.
You're
All
gonna save it to,
right.
and it's gonna start shooting a bullet at you.
Oh shit.
Oh shit! Oh, it hits itself at a certain point. That's unfortunate.
Oh, it does hit itself.
Oh,
Oh,
bummer.
it just shot the shit out of itself.
Mm-hmm.
Is that because we're not putting it far enough ahead?
Probably, yeah. So right now,
Oh,
if you turn the player to face quadrant two, like where, yeah, if you point the player in that direction as well, does the player bullet hit itself? Because it should, right? No.
well, the hitbox for the player is narrower than the hitbox for the turrets.
Oh, interesting.
So let's.
Yeah, I love that you got to bolt it. Oh yeah, no.
It still hits itself.
Yeah, that's a bummer.
That's reasonable progress, though.
Oh my God,
That is a
that's
killer. This
that's
is a real.
delightful.
Oh, I just shot myself. It's really
Oh,
hard to hit things. Oh.
well, you know it might be a fun. Oh, dude, you died.
Dark Souls, you died.
It could be very fun to have a make this a twin stick shooter for the tank because that's a tank,
You know what I want this to be?
huh?
What I've always wanted this to be is mouse controlled crosshair with WASD for moving the tank around.
That's what I'm thinking of in terms of twin stick. Yeah, like you got tank orientation and turret orientation, which would be really really cool.
Okay, well, we could work on that next time. Boy, that's
Yeah,
brutal. That cooldown period needs to be a little bit longer.
it's a little too much for the yeah.
And I love how the screen shakes every single time. It's like very much insult to injury. It's
Oh
really hard
right,
to aim.
yeah. I
At
wonder
least
if we
I
need
find
to
it.
no. We've made a game as hard as Bolo.
It's true. Oh, I could get good. I could get good at this.
Oh.
Oh, and I just love to think
Uh
that I
wow.
feel like
Cheater.
this, like, there's got to be some way that we can just like monkey with the numbers that it definitely doesn't.
I'm okay with that, but I really do want that to be a tag thing eventually.
Yeah.
Yeah, you gotta strafe close to it. That's the only way to get enough time.
I'm so bad at controlling the tank. It doesn't help that I drive faster than my own bullets. So we made a really fun game. Okay, so here's what I want to do now
Yeah.
is I want to spice up my life a
Oh,
lot.
Jeff. Oh, Jeff. Oh, that's so cool. Look at them all rotating independently. And then they're just stuck on the player. Oh, that looks awesome.
So I think if we have multiple turrets, the rate of fire needs to be a lot slower, right? But I think they need to be not screenshotting, screen shaking. It's just like they're very exuberant.
Yeah, what happens if we turn off turret screen shake? Because really, the screen shake is when a bullet hits you or when you fire the thing. Because,
We have too much screen shake right now. I think we just need to get rid of like
yeah. Oh my God.
death. I think that's the
It's
only
just
thing
having a
that.
little earthquake. Well, take it off the turret shooter. Let's get rid of that.
Okay.
Oh my
Oh,
God. They're just like zeroed in on you.
all right. Get rid of the camera shake there.
Yeah.
That gives us a little bit of a break. Well, I can have them kill each other
Uh-huh.
and
And I like
just
that you
stay
get you get a
politely out of
little you get a
range.
little feedback when that happens too.
You could make a game out of this. Like
Yeah.
it's just like Aikido the game. Just like use your enemy's energy against them.
Oh, I'm really a fan of games where you don't have a gun. It'd be interesting to make this a passive fist game.
Yeah, we could, or at least pacifist mode. Like there could be a level
Pacifist
where
mode. Yeah.
maybe the tagging of the bullets is such that like the enemies can hit each other.
hmm I want I want super hot, but you have to move people while time stands still as well in front of other people's bullets. People don't kill
Just
people,
gonna hide
bullets kill
walls
people.
here. Boy, we've got a game. Look at
Yeah.
that.
Isn't that great?
Okay.
Wow.
Well, that brings us to the end of this stream. Really fun. This is actually a lot. I thought it was going to be painful dealing with all the math stuff, but it ended up being stuff we could work through.
Yeah. Thank goodness
Just
for
looks
that
like
rotate
this.
function. We needed it.
And then we
Oh,
also talked
dude.
about rendering and shit. Cool. So upstream, we can continue to work on the tools. Get that having a real map editor in there would be really great. And then
I would love that.
a new input mechanic feels like the next thing in order because it's really hard to play the game at the moment, right?
Yeah, it'd be interesting to take a little tuning time because I'm curious if slowing everything down would make it easier. Like, yeah.
Yeah.
But yeah, new input mechanic would be cool too. I was thinking that it's interesting because then the AI for enemy could eventually be doing some sort of like move away while shooting at you to like you have to follow the shooting target that's like aiming backwards but driving forward. So
Yeah. I actually
mm-hmm.
kind of wonder if in the sphere of an RTS, the input mechanic is going to be really key to this game because I could imagine an input mechanic where you have almost StarCraft style navigation where you right click and your unit just pathfinds,
Mm-hmm.
but you could left click with the reticle and shoot in that direction while you're moving. Right, that would be a really fun mechanic. Right.
Oh.
Uh,
Oh yeah.
yeah, but that's definitely like a mouse and keyboard type thing. I can see you kind of do it with the stick, where you move the reticle around with the stick. It's just a little harder. Um,
Yeah.
but
We
the
we could add
other,
gamepad support.
yeah, the other, it's like the difference between. Actually, this is exactly Diablo, right? This is exactly the Diablo issue, where Diablo, when it was a PC game,
hmm
you would click to where you wanted the guy to go,
Yep.
but you could also like shift click and then shoot in that direction, like if you had a
It
ranged
was the only way to
character.
be an archer, yeah, or mage.
Yeah. That could be a rad way to play the game. But the other way to play the game is twin stick, where you're moving in one. You move the character using one stick, and then you orient
hmm
the attack using the other stick. Um, which
Yeah,
I
we should try both maybe.
yeah Yeah, we
We
should
could
try
flip
both
it.
and see
We
what
could we
see.
could we could have a configuration to switch control methods.
With twin stick shooters, accuracy at distance becomes a real problem, right?
Hmm.
Because how fine grained you can get in terms of rotation is it's pretty rough, and it gets
Yep.
worse as you're farther away, right?
Yep. Well, I always thought that was maybe the trade-off for that sort of stuff too, where you have to get in a little closer to be effective.
Yeah, that's right.
Yeah.
Or you get weapons that do sweeps, right? You can do kind of like
Ah, so
flamethrowers kind of
good.
stuff.
Yeah. Oh man,
See,
we should make some different kinds of bullets too, like flamethrowers that are little particle waves. Oh, that'd be neat.
yeah. So we're all militarists in the end. That's the lesson for today.
Yeah.
Militarists for whom, right? This is not a neutral kind of thing, right?
Well, yeah, I mean, like, do you want to take inspiration from Tonight We Riot and make this
Oh, absolutely. Yeah. I
yeah,
mean,
like,
our fucking game is about like Rebel Alliance versus the Empire,
perfect.
Indiana
Yeah.
Jones versus the Nazis, protesters against the cops. It's absolutely that, right? It's
Yeah.
going to be like a punk proletarian goth tank driver killing fucking alien Nazis,
Oh my God, I'm
something
so
like that.
into it.
We're
Have you played
strategic.
Tonight We Riot yet? It's good. It's fun.
Okay.
It's just charming, and then like you get to the second world, which is Bootlick Bayou, and I'm just like, you know what? These people know what's up. They're having a good time. I was happy to just give them a little money.
Okay. Yeah, I'm down with that. Should I also play Dead Cells as well?
Less politically interesting, but giving them money is good.
They're also of the collective motivation, right?
They're like a pure collective. Yeah, their politics are in their studio and not the game, but like the studio seems really cool.
Yeah, I'm interested in that model. And like the thing
Hmm.
is, like people have been doing it successfully for a while. Like Cheeseboard is a worker-owned cooperative, and
Yeah,
they're the very top of their game, basically.
it's like we understand how to do it for retail, but not like in software. It's sort of like, oh, what are you doing?
Why is it? I think it's purely what we assume to be normal, right? And I
Hmm.
think that's basically it's just purely historical, right?
Exactly.
Yeah.
Uh,
All right.
this is gonna be really fun. I mean, it already is, but we're gonna have to do some like game design and story writing on stream.
Well, yeah. Hopefully, this thing will be ready to go next week. I don't know if next. I'm starting work again tomorrow, so I won't be absorbing all my daylight hours in this kind of thing. But I like building tools. It's fun. It's
This was
actually
your
really
week off project. Hell yeah.
yeah. Or
I was
my last couple days of my week off kind of project. Yeah, for sure.
I was very inspired by the that tile editor we had on stream last time, or maybe two streams ago. But it would be really cool to have like a mode where you put down some water and it actually like expands a little bit too. I'd love to play with some randomness in this to get more organic structures versus just pixel painting
It's actually
someday.
why I did the noise demo because I was
Ah,
trying to
cool.
think like if I wanted to like paint with a wide brush and get some noise in there.
Yeah.
Um,
Or like the
maybe what we're
mountain, like
talking
when you hold down mountain, it could like it could grow from the center. Yeah.
maybe what we're talking about is having terrain that has features, right? Like,
Hmm.
and that would be like sort of the dwarf fortress style of thing, where like visually it's not that interesting, but what we are talking about is like different levels of gradation and that sort of thing.
Have you
Um,
seen the remaster? Because now they have high def graphics.
what? All right.
Yeah, Dwarf Fortress just redid itself.
Uh, remaster.
I just like go to Steam, go to Dwarf Fortress Steam, and I think it's now get ready to have your mind blown.
Holy shit!
I
Wait. That was a little fleeting, wasn't it?
mean, this was the announcement, but it's if you go to the Steam page, it's all there. Like it's out now.
Okay, God. There's
Yeah,
dogs. Oh my
even
God.
Dwarf Fortress has better graphics than us now.
Can you pet the dogs?
I don't. You gotta check the Twitter account. I'm not sure.
Yeah, I don't know. Is this better?
Oh, there's a cat too. I mean, they at least have more. Oh, look
Dogs
at
are
that.
lowercase t's.
I can't even deal with the original game. Holy cow.
Yeah, you know, every time I read about Dwarf Fortress, I'm like, I don't want any part of that. It just seems like such a huge pain in the ass.
Yeah. Oh my
It's
God,
like
that's
it's
ridiculous.
it's like playing it's like playing versus mode against Roko's Basilisk. That's what I imagine. That's what I imagine playing Fortress, you know.
Oh, that's
Anyways,
so funny. Oh, wait, Jeff, I think it's actually changed dramatically since that video too. They might have made it
okay.
isometric.
Dwarf Fortress isometric.
Maybe it's just a mode in this now.
I mean, I meant like I actually don't. I accept your cookies. Oh my god, this is friggin' rad.
Now you want to play it.
Well, I think our game needs to be isometric. It
I agree. We should do it.
needs to be isometric in 3D with some zoom.
Mm-hmm. Mm-hmm.
Gosh, this game's gonna be rad. It's gonna come together, and it's gonna be about killing Nazis
I'm into it.
ultimately.
Sounds like a wonderful way to spend the time. Just wait till our stream gets brigaded. That's what we have to
Yeah,
look forward to.
wonderful.
Yeah, if we're gonna make a gun game, let's at least make it a good gun game.
Tanks, tanks, of
Hey,
course, the true weapon of the revolution, right?
hey man, maybe our protagonist liberates a tank from the cops and yeah, goes on a spree of freeing the people. I'd play that.
Yes.
Yeah.
When I was a kid, we'll end the stream like this. I lived in a town called Valencia, which is part of a city now called Santa Clarita,
Hmm.
of Santa Clarita Diet
I
fame.
really I really enjoyed that show.
Oh, good. I'm glad.
Yeah.
But that's where I grew up. Kind of
Cool.
like interesting. It's actually where Katie Hill was the I think congressional representative.
Mm.
She was a someone who was we were very happy to put into Congress on the not Trump side
Hmm.
in 2018, and then had a sexual scandal and then was forced to resign. And that seat is probably going to flip to the
Oh, that was
GOP.
her.
That's
Oh.
her. She went to my high school, actually. Uh, but I want to talk about tanks. There was in one corner of town one of those like cop battering ram tanks. Do you remember the movie Dragnet with Dan Aykroyd and Tom Hanks?
Yeah, but I never saw it.
Okay. Well, there's a scene where they actually drive one of these like cop tanks. They're basically just like this was like the 80s version of like police militarization where they bought a tank, but the turret instead of firing actual ordnance, which
Hmm.
is probably not very justified. I mean, police have literally like air bombed black people before, right? They like I think in Philadelphia they literally like air bombed people, but um, I think having an actual tank on the police force is maybe a couple of years down the line. Still, like we haven't quite crossed that line yet. But they had a tank, but the turret was just a battering ram, so it was just like like a long thing with like a little like reinforced tip. And a guy when I was in like high school or junior high, like just like broke into a lot and like just like jumped into the driver's seat of this thing, flipped down the vanity mirror and like grabbed the keys or something like that, and just like turned the thing on and goes on a rampage
Oh
in my
no.
town with the tank. So our game is about that guy.
Oh, I like it. Yeah, yeah, yeah.
We
Oh
should we should
man.
have this. We should have a moment like the beginning of the game is like you start out and you're the guy. You're not
You're the
actually the
guy.
tank. You're the guy, and you're running around and you're like running away from the guard dogs or some shit. And the only thing you can do is hop into this tank. And
Well,
it turns out to be like a research facility with like the world's greatest like prototype tank. And
yeah.
now it's in your hands.
The tank AI is too smart and it develops class consciousness and it's ready to take down its oppressors too.
Oh yeah, the tank is fully aware of the
Yeah.
contradictions of the economic system. It's just like laid plain, right?
This would be really I thinking about just the different ways that we could actually like approach this in terms of enemies as well. Like we actually have the entire, oh, thank you. We have the entire spectrum of like strange militarized police gear as our slate of enemies too. Like we got ATVs, we got turrets, we got helicopters. We could lean into that.
There'll be drones. There's gonna be some robot dogs.
Oh,
There's gonna be
drones and
some
robot dogs.
yeah,
Yeah, yeah, yeah.
robot dogs. We got some homing missiles for you.
Well, this this took a turn for the creatively interesting, and I like it.
Cool.
We got
Yeah,
to go isometric and get some art in here soon, so we can really like lean into it.
definitely. This will be a kind of like fabulous, kind of like orgasmic proletarian fever dream, right? Like, and I technically I have problems with that genre. You know, what is it? Inglorious Bastards, the Tarantino
Hmm.
film.
Hmm.
Um, awesome movie. I love so many things about it. I always felt uncomfortable with just the premise of like killing Hitler and whatever, because it's like it's not actually what happened. Like what happened in reality was the exact opposite of that, really. You know,
Yeah,
and
I loved that it was like it was fantasy though. It was like historical fantasy. It was, and that movie and Django are the only two movies I really can point to be like, oh yeah, okay, no consequences.
right. And for some reason, on the one hand, it's like that's kind of like the visceral thrill at the end of those movies, and on
Hmm.
the other hand, I like walked out of both of them feeling deeply uncomfortable because
Hmm. Yeah.
it's why the end of Brazil is tragic, right? He can have that fantasy while he's getting lobotomized.
Yep.
Anyways,
Yeah.
I'm gonna enjoy my last night of freedom and play the shit out of Yakuza and beat the crap out of other Yakuza. That's what you do in that game.
There you go.
It's
Well,
basically.
fuck yeah. Stay safe.
You too, man.
I hope the BPD doesn't do too much terrible stuff tonight, but I've met them.
Is there action in? Is there any collective action in Berkeley, or is it Oakland still?
I think it's Oakland and SF still, so Berkeley will probably be in someone else's town messing stuff up.
Yeah,
Great.
we'll see how many Amy Coopers come out of the woodwork in Berkeley. Uh,
Well,
I feel like there's a lot, right? I feel like that's yeah.
yep. Well, cool. On that note, I'm going to stop the stream. Goodbye, everybody, and see you on Wednesday.
Take care, everybody. Stay safe.
Peace.